everybody. Let's get back into some solving linear equations algebraically. So we're going to solve linear equations with one variable to model and then solve real-world and mathematical problems. And we're going to be using some things called the distributive property and collecting like terms, okay, which I think we saw a little bit in the previous section. So sometimes equations have variables on both sides of the equal sign, okay, and this is going to require some a bunch of steps. So let's walk through a couple examples right here, and we'll kind of get through the best way to tackle these problems. All right, so example A is kind of worked out for us. So let's just talk through the steps and make sure we're clear on what's going on here. So the original equation there, 12x plus 5 equals 6x plus 17. And you'll notice in this problem there are terms of x on both sides of the equal sign, right? So that it's very important that we recognize the equal sign is here. So we have 12x on one side and we have 6x on the other side. So in this case, we're not combining those terms because they're actually on opposite sides of the equation. We'll see in a later example what we saw before was when we could combine like terms. But in this case, we are going to get rid of or subtract 6x, as you see in step 1, because what we want to do, we want to get the variable x by itself. Okay, so it's kind of like combining variables, but it's not, at this first step at least, it's not combining like terms. But what we can do, okay, again, here's our original equation. Generally, if there's variables on both sides, you want to subtract the smaller of the two so that you don't end up getting a negative. So that's why they subtracted 6x from both sides as opposed to subtracting 12x from both sides. It's just a way, again, to keep your next step to have all positive terms. Okay, so you see what they did? They subtracted 6x from both sides. So that's going to be combining the x's here. The 12x minus 6x just turns into 6x. Okay, and then we still have the plus 5 there. Now on this side of the equation, the 6x, when we subtract the 6x, it goes away, and we're left with just 17. Okay, so we've kind of got it to the point now where there's only variables on one side of the equation, and now our equation is just 6x plus 5 equals 17. And again, just always keep in mind, your goal, you want to get that x by itself. So we're going to get rid of the other things on that side of the equation. Okay, so we are going to subtract the 5 from both sides, and we'll be left with 6x then equals 12. Okay, because again, this minus 5 is just being done to undo the plus 5. It's the inverse operation. And then when you're left with 6x equals 12, if your equation is telling you 6 times some number x equals 12, in order to find x, we would do the inverse of times, which is going to be divide, and we will divide both sides by 6, and we will be left with our answer of x equals 2. Okay, so that's using inverse operations, and you can always check your equations. We could go way back to the original problem up here and verify that if we want to check that x equals 2, okay, you can always plug it back in, meaning the original was 12 times x. We're saying x is 2. Does 12 times 2 plus 5, does that equal, the other side of the equation was 6 times x plus 17. And when I'm checking, I like to put a question mark because I'm not stating for sure those things are equal. I'm going to check and make sure that they are. And you can see that process they did down here kind of verifies that our answer of x equals 2 was correct. All right, so let's take a look at a couple other examples. There's a couple down here on the try these. Let's start with part A. We'll do this one together. It's kind of a tricky one, or a lot of stuff going on. So the original is 2 minus 3 halves times x plus 1 equals 6x minus 9. Okay. I love when books do this. They kind of give you the nice, easy example, and they go through the steps, and then they throw you this one with fractions and parentheses and all this stuff to do on your own. So I figured let's do this one together. All right, so a few things going on. So pretty much whenever you see a number times something in parentheses, okay, that's when we're going to be using what's called that distributive property. Okay, and we saw this in the last section. So let's kind of review how that works and see if that can help us then simplify some things. So what the distributive property tells us is that that 3 over 2 is going to actually get multiplied by the x and then also by the plus 1. Okay, this 2 at the very beginning, we can't combine with anything yet. Okay, it's going to be 2 minus, and then we need to do this multiplication. Okay, we can't do the subtraction first. So 3 halves times x is just 3 halves x. And then we have, remember we do have a minus sign here, it's minusing 3 halves times 1. Okay, and anything times 1, of course, is just itself. Okay, so here's our equation. We at least took care of the distributing. Now we have a couple things to do. Okay, we have variables on both sides of this equation, right? There's x's on the left side of the equation and the right side of the equal sign as well. Okay, so why don't we try and get those on the same side? And again, we want to, if possible, to do this in a way where we would have a positive number of x's. So instead of subtracting the 6x that's on the right side, let's add the 3 halves x to both sides of this equation. And then we won't have a negative, right? We won't have to be dealing with negatives. It's not the end of the world if we did, but if we have the option, let's do it this way. Okay, so what we're going to have, the adding 3 halves x, okay, what that's going to do is going to cancel out this minus 3 half x. So we're going to have 2, and we still have the minus 3 halves, and we can combine those two numbers in just a second. Okay, now we have 6x plus 3 halves x. Okay, so in this case, if we wanted to, we need to add 6x. Let me just do this on the side here. 6x, and we need to add 3 halves x. So one option would be to convert the 3 halves to a decimal, and that's totally fine. But I want to just make sure we're familiar with how to get these as fractions. So to add the 6 and the 3 halves together, they need to have the common denominator. So the 3 half x is fine. The trick is I'm going to rewrite 6 so that it has a denominator of 2 as well. So 12 over 2 is just another way of writing 6, right? These are equal to each other. And what it's going to allow us to do is just add these together now, because they have that common denominator, so we can simply add the 12 and the 3 to get 15. Okay, so 15 over 2x is what we get when these get added together. And then we do have the minus 9 still sitting there. Okay, so we combined the like terms. We added those x's. It did involve some fractions and stuff like that. Okay, now we got a couple more steps. To combine these like terms right here, we need to do something similar, right? Because again, they're fractions being subtracted. We need to have a common denominator, so we're going to write the 2 as 4 over 2. Okay, minus 3 over 2. Okay, and I'm just going to keep writing this side. If there's an x in there. And what I want to do is just keep going and keep simplifying. Give ourselves a little bit of room here. Okay, so we rewrote the 2 as 4 over 2 so that I could combine these like terms. Okay, it's 4 halves minus 3 halves is going to equal 1 half. And we have the 15 over 2 times x minus 9. Okay, so again, this is kind of a messy equation, a lot of things going on, but we can handle it. So let's take a look. Keep it moving. We have now 1 half equals 15 over 2x minus 9. Okay, and again, our goal in any equation is to get the variable by itself. So let's start getting rid of things around the variable. And we always do the adding and subtracting first. We're going to add 9 to both sides. Okay, that's going to cancel out the minus 9. So we're going to have 15 over 2x. And then 1 half plus 9. Okay, 1 half plus 9. 1 half, let's do this on the side here. 1 half. If I'm going to add 9, again, I need a common denominator. So 9 is equal to 18 over 2. So this side of the equation, when we combine those together, ends up becoming, if we do 1 over 2 plus 18 over 2, we're going to get 19 over 2. Okay, and so now we have 19 over 2 equals 15 over 2x. Okay, so what we want to do, just trying to give myself some room to work. There we go. Is get the x by itself, right? So we would need to divide, since this is 15 over 2 times x, I would divide both sides by the 15 over 2, and that would help me get x by itself. Okay, so let's do that over here. So what I'm going to be doing is taking the 19 over 2 and dividing by 15 over 2. So remember, to do that, you multiply by the reciprocal. So we're going to take 19 over 2. To divide by a fraction, we multiply by its reciprocal, which becomes 2 over 15. Okay, and we can also reduce these fractions. The 2 divided by 2, those can be reduced to 1. So this is going to end up equaling 19 over 15. Okay, and these canceled out, so that is just going to end up being x, and we got our answer. And I'll admit, that problem was a doozy. I cannot believe, like I said, that from the one example they gave, that they gave you one to try on your own, and the first one was like this. So if you're with me on that one, we're in good shape. Let's walk through one more though, just to get on the steps. But again, that one had a lot of fractions and a lot of stuff going on. But hopefully we were able to stick with that. All right, so let's do example B. All right, part B from that same one was 2 times x plus 0.7 equals 6 times x minus 0.8. All right, so we got a few things going on here. We have, looks like we can distribute a value, right? Because I have a number times something in parentheses, and we actually have that on both sides of the equation. So we can do that. Okay, there are other options here, but I'm just going to kind of go through. That's probably what most people would see to do first. So if we multiply the 2 times each of those, 2x plus, if I do 2 times 0.7, that should give me 1.4. Okay, and the same thing over here, multiplying or distributing that 6 to both gives me 6x minus 4.8. Okay, now we're at that point again where there are variables on each side of the equal sign. There's one on the left side, one on the right side. We want to get it to only be on one side of the equation. So let's subtract 2x from both sides. And I chose the 2x on purpose again, right? I don't want to end up getting a negative if I don't have to. So that's why I subtracted the smaller one. And take a look what that's going to do for us. The 2x and the minus 2x on the left side are going to cancel, and we will just have 1.4. Okay, on the right side here, 6x, if you take away 2x's, you will be left with 4x. And then don't forget that minus 4.8 still sitting there. Okay, so now our goal is to get this x by itself, right? So let's get rid of everything on that side of the equation. Let's add the 4.8 to both sides. Okay, that will cancel out the minusing 4.8. And this would give us what? 2 carry the 1, so 6.2 is going to equal 4x. And again, now they're telling you 4 times something equals 6.2. Okay, the way we're going to undo multiplying by 4 is to divide both sides by 4. Okay, so x is going to end up equaling, if we take 6.2, divide by 4, okay, that's going to give me a value of 1.55. Okay. All right, so that is a couple examples of solving equations. Okay, we were using the distributive property as well as combining like terms and seeing variables on both sides.